Morning, everybody, or I guess afternoon. Sorry if you hear some noise or see somebody walking around. My boyfriend and I are sharing an office, so fun times. So today, the lecture is going to be super short. I feel like I say that every time, and then you end up listening to me for 30 minutes, but this time it's actually going to be pretty short. Because I don't even have a PowerPoint, I'm just going to walk you through a few things on the lab page. Point out a couple of things for you, and then I'm gonna let you get to it. Mainly because this week's lab, the Marine Adaptations lab, I should say, depending on which lab you're gonna do. Um, the Marine Adaptations lab has a ton of videos for y'all to watch. So instead of sort of spending a ton of time going through it and then you just listening to the same thing on the videos, I'm just going to point out a few things and then let y'all get to it. So some things are this Marine Adaptations Lab has a bunch of extra sub pages. So they're all relatively short. They've got a short video and then, just some main points that follow. So make sure that you are looking at those. Like, for example, this is literally the only thing about anglerfishes on here. So it's not, a whole other lab to read through. It's just the main points. So I just wanted to point that out to you and then talk to you about a few things for the marine adaptations, and then I'm gonna let y'all get to it. Oh, also before I forget, I changed the form settings so that you can go back and edit previous submissions. So that means that you don't have to do the lab like all at one time. Like you could finish it, turn it in, and then, you could do some of it, submit it, and then, come back and edit it. As long as it's, done by Sunday, it's good to go. So even though it's going to probably feel weird submitting it without it completely done, you can just do that, and then you can, again, like I just said, edit it. The only problem that might pop up is that all of these answers are, required. So you might have to fill in like, a letter or something into the boxes so that it counts that it's been answered. But then, like I said, you can just go back, re-edit it, and submit it. That way you don't have to do it all at one time. So let's get to it. So this is the main figure that I wanted to show you. This is a figure of the two different main zones of the marine environment. So marine organisms will either live in the benthic zone, which means the seafloor, so this white zone, or they're going to live in the water column, which is the pelagic zone. So within those zones, there are also different zones. So starting with the benthic zones, organisms could be littoral or deep benthic. If you guys took Latin in high school, maybe you'll remember that littoral means like shore or close to the seashore. And that in this case, it means the same thing. It means shallow. So benthic organisms that live in relatively shallow water. Well, they live on the surface in shallow water. And then there is deep benthic, which is benthic organisms that live in deeper water, basically. So again, you've got benthic organisms which live on the surface in general. And when I say the surface, I guess I should say the sea floor, right? So they live on the sea floor. And they live in two zones, either littoral or deep benthic. Your next zone, I'm going to clear this so that I can move this around. Your next zone is, sorry, let me get this Zoom thing out of the way, is the pelagic zones. And so pelagic zones, organisms can either live in neritic or an oceanic environment. And so neritic is all water that is overlying the continental shelf. So right here would be neritic, and then oceanic would be organisms that live out in the open ocean beyond the continental shelf. So if you think of this as a graph where y is depth and x is how far you are out into the ocean, over here on the graph, close to the hypothetical y-axis, you've got neritic and then oceanic. And then if we take a look at just factors like depth, we also have pelagic zones. So not only do we have neritic and oceanic organisms, but within the neritic and oceanic organisms, there are different pelagic zones. So the first is epipelagic, which is from 0 to 130 meters. So let's go ahead and just write that out. Epipelagic. I feel like somehow that I'm missing a P. There we go. Epipelagic is from 0 to 130 meters. Mesopelagic is from 130 to 1,000. Meso, middle. Mesopelagic is from 130 to 1,000. Bathypelagic is from 1,000 to 4,000. So unfortunately on Zoom, I cannot rotate this text box, I believe, unless they've decided to allow me, and I don't think so. But I can draw, so let's do that. There's bathypelagic, there's mesopelagic, and there's just epipelagic that doesn't even do the full thing because it's so small. And then from 4,000 meters and deeper, you've got abyssopelagic. I'm definitely gonna spell this wrong. That might be right. Abyssopelagic. If I zoom out a little bit. Abysso. Oh, so close. You can tell that spelling is not my game. So anything deeper than 4,000 and living in the water column is abyssopelagic. So if you've got, so on this graph, for example, this is, sorry, now I've got to read. One second. Of course, if you move Zoom, all of these things move. Thank you for your patience. So there we go. Bathypelagic, abyssopelagic. So on this diagram, pretty much anything deeper than 4,500 meters is seafloor, but in some that's not always true, right? We've got trenches or just deeper parts of the ocean basin that are deeper than this graph here and in the water column, and that's where those abyssopelagic organisms live. So just as one more reminder, when you hear the word benthic, I want you to think seafloor. Okay, that organism is living on the seafloor. And it can either be a littoral benthic organism, which is near or shallow water, or deep benthic organism. And when you hear pelagic, I want you to think water column. That animal is living in the water, swimming around. It does not touch the seafloor. And it can either be a neritic organism, which is in water overlying the continental shelf, or it can be an oceanic organism, which is in water, in deeper water that's beyond that continental shelf. So you'll see here, right, this is that, this is the shelf and this is the slope. So as soon as that slope begins, we've got oceanic pelagic organisms. And then within that oceanic pelagic zone, we can look at depth, right? Epipelagic is 0 to 130. Mesopelagic is 130 to 1,000. Bathypelagic is 1,000 to 4,000. And then anything greater than 4,000 is abyssopelagic. So the reason why we have so many zones is because there's so many different types of marine animals, and they all have adapted to these different zones in different ways. So if we scroll down a little bit. We can look at the main reasons for adaptation. So I'm just going to go through a few of these, and then literally that's it. I'm gonna send you on your way to begin this lab. But I just want to make sure that you are looking at these things. So light is one of the big reasons for adaptation. In the ocean, there are two light zones. The first is the euphotic zone, and the second is the aphotic zone. So in the euphotic zone, that's where organisms have enough sunlight to photosynthesize. So just like plants, right, on land, some ocean organisms use photosynthesis. And so in order to do that, right, they need sunlight. So they live in zones that have sunlight. Aphotic zones are zones where sunlight doesn't reach. They live in darkness, basically. So the euphotic zone is in the top 200 meters of the epipelagic and mesopelagic zones. Those zones, the wideness of the euphotic zone, the depth of the euphotic zone really depends on two things, turbidity, right? And also latitude. So it depends on turbidity because the amount of particulate matter floating in the water column is either going to block sunlight or let sunlight through. So if you think about when it's been raining for a long time and you go out for a nice walk the day after it stops raining, or maybe 2 days after it stops raining, and there's some puddles, and the puddle looks really, really clear, really, really clean, and then you decide to jump in that puddle, what happens, right? It kicks up all of this clay. That puddle is now a lot murkier, right? And maybe you can't see the bottom of the puddle anymore. So you can't see the bottom because of that particulate matter, right? That's floating around in the puddle. Well, if you were to somehow put yourself underneath the puddle and be looking up towards the sun, let's say that you're a tiny little organism that is in that puddle. Somebody jumps in your puddle and now all of a sudden things are a lot darker. And again, that's because of that turbidity. And then as far as latitude goes, the sun's rays are going to hit, or sun rays hit the earth at different angles, right? Because of the tilt in the earth and our position to the sun. So in the equatorial regions, that euphotic zone is going to be a lot wider because the sun's rays are hitting the ocean almost directly. Whereas in the polar regions, the euphotic zone is going to be smaller, more narrow, because the sun's rays are going to hit it at a lower angle. Okay, so that's two reasons why your euphotic zone might be bigger or smaller. Another thing to think about when we talk about environmental challenges or reasons why organisms need to or had to adapt is the amount of oxygen. So let's go back to my little drawing. So there are two sources of dissolved oxygen in the ocean. The first is the byproduct of photosynthesis. So just like here, we get our oxygen from plants. In the ocean, dissolved oxygen comes from organisms, I should say, that photosynthesize. And then the second reason is the atmosphere at the ocean surface. So ocean levels are going to decrease with water depth, right? Your dissolved oxygen is the highest at the atmosphere, at the Earth's surface. Ocean surface. I'm really messing up my words today. I'm sorry about that. The dissolved oxygen is highest near the surface of the ocean because it has direct contact with the atmosphere, so air that we breathe, right? And it's also where photosynthesis is greatest because it's getting the most amount of sunlight, right? Relative to that column of water, the surface is absolutely where there's always the most amount of sunlight. So as you get deeper down, away from the surface, your oxygen levels are going to decrease. Less sunlight, less contact with the atmosphere. So at that point, as you're making your way down the water column, we've started, let's just put a little surface thing here and maybe bottom here. I draw a nice little arrow, right? and our oxygen levels decrease from the surface to the bottom. So oxygen does find its way to the deep ocean through thermohaline circulation, which y'all learned about, I believe, in exercise 6 and 7. And also in density-driven vertical circulation, which y'all definitely learned about in 6. Remember talking about salinity and density with cold water? So through that sort of circulation, that density-driven circulation and the thermohaline circulation, oxygen does find its way in deeper parts of the ocean. And so because it's part of this circulation, right, it causes these differentiations in oxygen. So depending on the depth, the coldness of the water, and that and also the season, right? Because different seasons drive, especially that thermohaline circulation. There are different amounts of oxygen that reaches the organisms. And so they need to adapt to that change in oxygen, or if they're closer to the surface, they've got that constant source. It just depends, right? So wherever they're living, they need to adapt to the amount of oxygen that may or may not make it to them. And then I'm going to let you all read salinity, buoyancy, and temperature and talk about pressure. So the deepest oceans are between 4,000 and 6,000 meters deep. And so at that depth, the pressure is about 600 atm. So just to put it in perspective, here at the surface, the pressure is 1 atm. So that's about, at those depths, it's about 4.5 tons pushing down on your body, right? So you might be able to imagine that is a ridiculous amount. But you guys have already felt pressure from a ton of water on you, right? If you dive to the bottom of a pool, especially those deep pools that are deeper than 10, 12 feet, and you go to the bottom, your ears pop, you feel maybe like your head hurts a lot. And all of that is because this pressure is pushing on you at that point. So if you're feeling that at those small depths, imagine that, 1,000 times, at 1,000 times that depth. So even though we can't deal with those pressures, organisms have adapted to living there. And so it's just pretty crazy to think about, right? That anything can live in those conditions. So that's it for today, just sort of a little bit of a rundown. Again, this lab is a little bit longer because of these videos that I'd like for you to watch. But I think if you start now, maybe do like one video a day or one section a day, you can get it done in plenty of time and hopefully learn a lot. So short lecture today, but I hope you guys learned something. As always, if you need office hours or anything else, I've got office hours tomorrow from 12 to 1:30 and Wednesday from 12 to 1:30, and then I'm available, in the week. You guys know, you just have to email me. Alrighty. That's it. I hope you have a shout out. I hope you have a good week, and let me know if you need help or anything.
Thank you.
No worries. See you later. Bye.